Hey guys, and welcome to this tutorial series, and it's going to be like my geometry nodes course where I update it constantly with new content. Yeah, so if you just getting here, make sure to come back and check it out for new content. Okay, so yeah, what we're going to be trying to make is this particle emission that I did. You can see it's different versions of it, but just have a hand just emitting some particles. It's a very simple setup. You emit particles and then you add a shield here. Now you might want to use a particle system for this, but the particle system, because it doesn't render the particles directly. For example, if I have a plane with a particle system, these particles don't render directly in Cycles or in Eevee. You have to use an object like a cube, then use that as the instance. That's the object that is rendered. Now the problem with that is that now what would have been just one particle, that one particle is going to be made out of however many vertices this cube is made out of, and that's going to be multiplied by the number of particles. So if you have 1,000,000 particles, it's now going to be 8,000,000 vertices in your scene, which is going to be significantly slower at render, instead of just one particle for one particle. That's why you're going to be using geometry nodes, because rendering this requires a lot of particles, so we're going to need quite a lot. And also geometry nodes gives us a lot of control that the particle system doesn't give us. So this whole setup is made out of three major parts. We have the emitter, we have the turbulence force, and then we have the shield or the colliders, including the ground. And if you take a look at my project file, which should be provided, yeah, you see that I'm also emitting lights because I'm rendering with Eevee. Eevee unfortunately doesn't do mesh lighting. It does it, but it's not high quality enough to give us the lighting I needed. Instanced some lights onto the points to get that effect. Let's take a look at the setup we need. Let me just borrow the hand. I'm going to copy this. I'm going to come in here. The first thing I did is add a vertex group for the hands, for the palm. That way I can emit from the palms. But you'll see in some other examples, I'm not emitting from the fingerprints, from the fingers. I'm emitting from the palm itself. You can see here the whole palm is emitting. So that's going to depend on what you want. There are variations of this effect, like this here, where we have a lot of particles being emitted and with some turbulence. And here we have a pulsating effect, and just look at the waves it's creating, patterns it's creating on the ground. I have also here, this is much faster with more energy, and there is also this. All project files are going to be provided for you. So let's start with this here, emitting from the tips here. Just create a vertex group for the tips. We can create a new object like a plane, then bring in our arm. We should be under here, so this here. I set it to relative, and now, yeah, this is what we have. Let me hide the original hand. Just take a look at this. Okay, we can distribute points. You can distribute points on faces, but remember we had a vertex group, and we can get that vertex group using the named attribute. So, which was, I think, palm. If you take a look at this geometry and take a look at this, you can see that our fingertips are selected. So we can use that as our selection for the particles. Let me increase the density to 500, just like that. And all we need to do to turn this into particles is use a simulation zone. If you don't know what the simulation zone, you can check out my geometry nodes course. It explains most of these in detail. Let me also add my shortcuts so that you can see what I'm doing. So the simulation zone runs on every frame. So whatever you have inside here is going to be recalculated on every frame. So if we use the join geometry to add and use these points into this geometry, we can basically add points on every frame. And since our hand is moving, the position of these points is also going to move, which is perfect. But we also want them to be pushed out. So I'm going to just use a simple set position. Which direction is this? That would be the Y. So positive Y, maybe negative Y, negative 0.1, And you can see now these particles are being emitted going in this direction, just like that. Now we don't want it to just be straight like that. I don't want to see this pattern. I want things to be more random. So I can change the seed, which is going to change the position of those vertices when they are emitted on every frame. So to do that, I'm going to use a time node and use the frame as the seed. So on each frame, we get particles in different positions, just like that, to break up the pattern just a bit. Now, you'll see that in my version, in the original, I have some turbulence, basically, yeah, some bit of wavy effect. So let's add that. And turbulence is basically noise applied as force. So I'm going to create that. So let's use a noise texture, and I use another set position. I can apply this as the offset, and we get something like that. The noise usually comes with an offset, so let's subtract that to center the noise. So 0.5. Now you can see instead of going up, everything is staying in position. Our noise is too strong, so I can use the scale value and scale it down maybe by 0.5. Let's do 0.5. The frequency is too high, so let me use a low frequency so that we have large waves, just like that. I think that's interesting. But one thing you will notice is that we start to see some patterns forming. All the particles are following similar paths like that, which doesn't look great. Maybe that's what you want, but if you want to break that up, you can animate this noise. Now, you might be tempted to use 4D noise because it gives you this value that lets you animate the value. But if you take a look at the timings, you can see that this increases the calculation time significantly. If it's 3D, you can see we're using 7.4 microseconds, but when you change it to 4D, it almost triples that. So let's keep it to 3D and instead use the position as the coordinates of this noise. Right now is what it's using already. So if we use the position, if we connect the position, we won't see any changes. But we can now manipulate this by maybe animating the Y value or the Z value. We can even try scaling this up, maybe down, and you can see we'll get something quite different. So I'm also going to animate this value using a time node. Maybe animate this using the frame. So we'll get some bit of animation. Let me just bring this back to 1, to a scale of 1. You can see now how our noise is, how this breaks up our pattern. Okay, so we have our turbulence, we have our emission. Now let's work on the shield. So the shield can be anything. Let's start simple by using a sphere. We can even make it a half sphere. Yeah, let's make it a half sphere, just like that. And let's add it into a collection so that we use anything in that collection as a collider. Okay, so I can bring this in the whole collection, and I can hide this for now and set this to relative. And since these are real instances, we need to realize them first. And the way we're going to set up the collider, we're going to use geometry proximity. So use the proximity node, and it gives you the position. So if any of these points come close to the collider, they'll get the collision point position of that point. So I'm going to use a set position and use that position as the new position. So if we play back, we basically get the effect we want. These points, when they come into contact with the shield, they stick to the collider, but we are losing the emission point. So immediately when they are emitted, they are pushed directly to the sphere, which is not what we want. We want them to hit the sphere only when the distance is maybe less than 0. So let's do that. Fortunately, this node here also gives us the distance of each particle from the sphere. So we can use that to create a selection. So use a compare node to say if the distance is less than, let's say 0.01, then those points should get the position we are setting. So these particles will move, and when they get to the sphere, you should see that, yeah, the collisions are working. Perfect. Now let's also set up the shading in next lesson. So